All right. Ready to dive into some serious math? Well, maybe not too serious. We're tackling linear equations today.
Yeah, before you hit that stop button, thinking back to high school algebra, I promise this is different.
Exactly. We're not about dusty formulas today. We're on a mission to uncover how these equations are hiding in plain sight every single day.
And trust me, it's more exciting than it sounds. We've got some textbook excerpts to guide us. Fascinating stuff, really.
So, before we get ahead of ourselves, let's start simple. What exactly is a linear equation?
You know, it's funny. You can think of a linear equation kind of like a puzzle. You know those ones where you're missing that one piece?
Oh, I know exactly what you mean. Those are the worst.
Totally. A linear equation is all about finding that missing piece, that unknown. Imagine you've got a perfectly balanced scale.
Okay, I'm picturing it. Got my scales all set.
Now, you've got weights on both sides, right? And to keep things balanced, you need to figure out exactly how much that missing weight has to be.
So it's all about balance. I think I can handle that.
Exactly. And our source today breaks this whole balancing act down with the structure of a linear equation.
Yeah.
You've got your left-hand side, your right-hand side.
And that all-important equal sign smack dab in the middle, right?
You got it. That equal sign is like the fulcrum of our scale, keeping everything in check. Our course even gives us a great example. 2 by 3 equals a 7.
Let me guess. The 2 by 3 is on one side, the 7 is on the other.
Right on. And that sneaky little x there, that's our missing weight, the variable we need to figure out.
The source calls these balancing values solutions, right? Like, aha, we cracked the code.
Exactly. It's any value for x
Yeah.
that makes that equation sing true. But here's where it gets really interesting. These equations, they're not just stuck in textbooks.
No, that's what I'm talking about. Bring on the real-world examples. Where are these linear equations lurking in our everyday lives?
All right, picture this. You're building a bookshelf, you've got a limited amount of wood, and you absolutely need to make sure those shelves are the perfect length.
Okay, I'm starting to see where you're going with this.
That right there. That's a linear equation waiting to happen. You've got your total length of wood, like the perimeter in that rectangle example our source talks about.
And you've got to figure out the length of each shelf.
Exactly. Our source uses the example of a rectangle with a perimeter of 13 centimeters and a width of 3 2/4 centimeters. Using a linear equation, we can find that missing length.
So even building a simple bookshelf has hidden math behind it. What else? What else? Where else do we find these undercover equations?
Oh, I think we've all been there. Imagine this. It's latte time, you know you need that caffeine fix,
Oh, tell me about it.
but you've only got that jar of coins.
Ugh, yeah. Is it even worth counting?
Well, our source actually tells this story about a guy named Bansi and his coin collection. And get this, he's got a mix of 2 rupee and 5 rupee coins.
Okay. Sounds like my coin jar situation.
Right. But here's the thing. He's got 3 times as many 2 rupee coins as 5 rupee coins. And the total value, a cool 77 rupees.
So the challenge is to figure out how many of each coin he's got.
You got it. It's like a coin puzzle. But no worries. Linear equations to the rescue.
All right, let's hear it. How do we solve Bansi's coin conundrum?
So we can use x to represent the number of those 5 rupee coins. And since he has 3 times as many 2 rupee coins, that would be 3x.
Okay, I'm following so far.
Now, think about the total value. Those 5 rupee coins add up to 5x rupees, right?
Makes sense.
And the 2 rupee coins, they bring in 6x rupees.
So we've got 5x plus 6x, and we know that has to equal...
77 rupees.
Wow.
Boom, we've got our equation. 5x plus 6x equals 77.
So just like that, we're back to balancing that equation.
Exactly. Solve for x, and you've cracked the code of Bansi's coin collection.
Building shelves, counting coins, these linear equations are everywhere.
They really are.
But, you know, our source also mentions these equations that are, and I'm quoting here, reducible to the linear form.
Yes.
Sounds kind of intimidating, like some next-level math. What's that all about?
Don't worry, it's not as scary as it sounds. Think of it like this. You know when you've got that really tangled up knot?
Oh, yeah, the worst.
At first it seems impossible, right? But with a little patience, you can untangle it, make it nice and smooth.
Okay, so these are like equations in disguise. They might look messy at first.
Exactly.
But we can transform them into those friendly linear equations we know and love.
You got it. And our source gives a perfect example using fractions. They start with this equation x divided by 2 by 3 plus 1 equals 3/8. Now that's a mouthful.
Whoa, fractions and variables in the denominator. This equation means business.
Right. But here's the thing. We can actually get rid of those fractions. We multiply both sides of the equation by the least common multiple of those denominators.
So we're like strategically simplifying things. I like it.
Exactly. It's like we're clearing away the clutter to see the solution more clearly. And when we do that, that kind of scary equation, it transforms into something much more manageable. 8x plus 8 equals 6x plus 9.
And just like that, we're back to our comfort zone, ready to solve for x. This is way more satisfying than that tangled knot analogy.
Right, and you know what's cool? This whole idea of transforming equations, it's not just about x, you know? It's like a way of thinking. We can take something super complex, even messy, and find that hidden structure within it.
Whoa, deep. So we're not just doing math here, we're like mathematical detectives, uncovering hidden patterns and stuff.
Exactly, I like that. And the more we get comfortable with these ideas, like linear equations, the more we can handle anything life throws at us.
Okay, so as we wrap up our linear equation adventure, what's the main takeaway? What do we want our listeners to remember?
I think it's this. Math. It's not just about memorizing a million formulas or whatever. It's more like a language, a way of looking at the world around us, you know?
Okay, I'm listening.
Linear equations, they're like these secret tools, quietly working behind the scenes in our everyday lives.
It's like they're the key to understanding, like everything, from building those bookshelves we talked about to managing our money, right?
Exactly. And the more we recognize those patterns, those connections, the more we realize that math, it's not just practical. It's actually pretty cool.
I have to say, this has been an eye-opening journey. Not only did I brush up on some math skills, but I feel like I've gained a whole new appreciation for linear equations.
It's been great diving into this with you. Just remember, the real magic of math is that it helps us see those hidden connections all around us. Keep exploring, stay curious, and who knows what you might find.
And on that note, we'll wrap up this deep dive. Until next time, keep those brains engaged and stay curious.